So we have a new topic here, the topic called calculus, and we are focusing on the part called differentiation. Now, what do we need to know about differentiation? The only thing that you need to know is how to differentiate using the power rule. So mostly in the exam they may ask you to differentiate the following, or they can say find dy dx, or they can say find the derivative. So whatever they mention, just know that the way you're going to go about it is using what we call the power rule. How does the power rule work? The power rule tells us to say for us to find the derivative, or yes, the derivative of these problems, we need to multiply the power times the number in front of x, which is a for this manner. So we are multiplying the power times the number in front of x. Then what do we do to the power after we multiply? We subtract minus 1. So what do we mean by that? Let's go to some examples. So solutions, we are saying that to differentiate this, or to find dy dx, or the derivative, we are going to have 3x to the power 4 minus 2x squared plus x. Alright, so we are told to say we need to multiply 4 times 3, so I'll say 4 times 3, then x will be just like that, nothing happens to x. Then we are told to say on top we need to subtract minus 1. Alright, even here we come, we say 2 times negative 2, so I'll say 2 times negative 2, then x like that, 2 minus 1, then plus. Here, whenever you see x alone without a number, whenever you are differentiating x which is standing alone without a number in front of it, just know that your answer is equal to 1. So you multiply each term, you differentiate each term alone. So that's why you are seeing as first we are differentiating this one, then we go to this one, then finally we go to x, which is just going to be equal to 1. So 4 times 3, we are going to get 12x, alright? Then 4 minus 1 will give us 3. Then, so here even include, say, dy dx is equal to, don't forget to include the dy dx, 12x cubed is minus 2 times negative 2 will give us negative 4x. Then 2 minus 1 will give us 1. We can put the 1 or we can't, because any number to the power 1 or any letter to the power 1, it is that same letter itself. Then finally plus 1, because when we differentiated x, it gave us 1. So every time that you differentiate x, just know that your answer is 1. Right. So I'll go to the second example. I have 4x to the power 4 plus x cubed minus 2x plus 3. Alright, so we are going to do the same. 4 times 4, we multiplied the power times the number in front of x, then to the power 4 minus 1, then plus 3 times x, since there is no number in front of x, so it's just be 3 times x to the power 3 minus 1, then minus. Here again, whenever you differentiate a number, or you differentiate a term that has got 2x, 5x, or 10x, as long as x does not have a power, or as long as x, the power of x is 1, just know that when you differentiate that term, your answer will just be the number in front of x. So here when we differentiated x, we got 1, because the number in front of this x is 1, so that's why we are putting 1. Then here, since the number in front of x is 2, we are going to put 2. So whenever you differentiate a term having x and x has got no power, just know that your final answer will be the number in front of x. Then whenever you differentiate a number that does not have x, your answer will be 0. So what we normally do to make things faster and easier is, whenever you are doing differentiation, when you meet a number, we call these constants. They do not have x or any letter attached to them. So whenever you find a number that does not have x attached to it, just know that your answer is 0 and just leave it out. Proceed with what you are remaining with. 4 times 4, which is 16. 16x. 4 minus 1 will give us 3, plus 3 times x will give us 3x. 3 minus 1 will give us 2, then finally minus 2. But I shouldn't forget to include my dy dx like that. We continue with some more examples. So we are now looking at this particular set of examples. We see how we can answer them. So we've got question number 1. They've told us, say, find dy dx of the following. So we've got question 1 that is saying 3 over 4 x to the power 4, okay, plus 2 over x squared minus 3x cubed plus 10x minus 4. So plus 10x minus 4. Alright, so we are doing the same, so it will be 4 times 3 over 4x, like that, because the number in front of x is the fraction, which is 3 over 4. Then we say the power 4 minus 1 plus. Here, this is where the trick is. Whenever you notice x is placed down in the fraction, or x is the denominator, what you are mandated to do is to make sure that x comes on top and it is attached to 2. So how do you do that? It's simple. All you need to do is to say 2x, like that. Then this power 2, which is on x here, on top when it comes, and it is attached to 2, when it comes on top, when x comes on top, it is going to be to the power negative 2. Alright, so now we are having x immediately attaching itself to 2. So 2x to the power negative 2. That is how we change this to become in the way that all other terms are. So it will be 2x to the power 2 minus, okay, minus, we've got 3 there, times 3x.
How is it going with the making?
So remember, whenever we differentiate a term that only has x, we just have that term itself. Then the one that is remaining alone without x is just as same as 0. So 4 times 3 over 4 will just give us 3x to the power 3 plus, okay, so here we haven't yet multiplied, so we need to multiply this power times the number in front of x. So it will be negative 2 times, okay, negative 2 times 2x, like that. Then we say minus 3 times 3, 9x squared plus 10. So we have 3x to the power 3, the negative 2 times it. So here we have the negative 2 minus 1, like that. I forgot to subtract the 1. So negative 2 minus 1, like that. Alright, so negative 2 times positive 2 will give us negative 4x to the power negative 2 minus 1 will give us negative 3 minus 9x squared plus 10x. Then we can't leave this standing the way it is with the negative power. So how do we change it? To go back to the way it was before, it will just be 4 over x to the power 3. So that even if we were to take it back to become in this manner, it will come and be to the power negative 3 minus 9x squared plus 10, like that. So this is how we work it out. Okay, then from there we go to the second example, where we have 2 over 3 x to the power 3 plus 3 over x plus 2x squared minus 3x plus 1. So it will be 3. So first I'll start with first converting this so that I make things easier for us. So it will be 3 the power x. So this x are there initially the power 1 there. So when it goes up, it will have negative 1 plus 2x squared minus 3x plus 1. So now we can start working them out. So here don't forget dy dx. So I think I forgot that. Dy dx is equal to, so 3, here we are going to have 3 times 2 over 3 x to the power 3 minus 1 plus, so here yes, plus we have negative 1 times 3 x to the power negative 1 minus 1. Then we say plus 2 times 2 x to the power 2 minus 1, and minus When we differentiate this with x alone, we just remain with 3. Then this one is the same as 0. Now we say dy dx, okay, dy dx is equal to 3 times 2 over 3 will give us, will give us 2x, 3 minus 1, 2. Then here we multiply negative 1 times 3 will give us negative 3x to the power negative 2, negative 1 minus 1 will give us negative 2, plus 2 times 2 will give us 4x to the power 1. Of course, we don't indicate the 1, and we say minus 3. Then we can't leave this one with a negative power, so we change it. So dy dx will be equal to 2x squared minus 3 over x to the power 2 plus 4x minus 3. And that's how we differentiate.